So, good afternoon, everyone. It's great to have you join us for our webinar today. My name is Nadia Gupser, and I'm an account manager for DBI Services in Basel. Leading the webinar today will be Nicolas Jadot, who will be talking to you about implementing SSO to manage your users in the cloud. I guess most of you already know DBI Services, but for those who are not familiar with us or just want to hear it again, DBI Services is an IT company with various locations in Switzerland. So it allows us to be there for you almost anywhere in Switzerland. Our main business yet is on consulting and SLA contracts, but we also offer other services. Products such as YAC and OM-Run are part of our portfolio and providing already great value to some of our existing customers. Our blog is also worth checking out, where experts share their experience for free. You can find all the information on our website, and also feel free to contact me or our colleagues at any time. It's also worth mentioning that we are ISO certified in the area security and SLA management. And I think when Nicolas talked about the implementing SSO to manage your users in the cloud, you have also time to ask some questions. And with that, I would already pass the word to Nicolas and wish you a lot of pleasure.
Thank you, Nadia. So today, as Nadia said, the subject is single sign-on or SSO in the cloud. So Nadia spoke a little bit about DBI, so I won't add much more on it. A few words about myself. So I'm Nicolas Jadot, working for DBI since more than 10 years now. Started on the database business and then moved to the cloud. So I'm principal consultant and technology leader on the cloud technologies. I have a few certifications as shown in the slides. And I think now we can move to the more interesting parts. So I'll split the presentation in three main topics. Why do we want to use SSO or single sign-on? Then I'll have two demos on implementing SSO. And then a few words on how we can go further, because the subject is quite wide and we can speak about it for a very long time, and we have only 1 hour. So let's go. Why using SSO? So first, I'll start with a small disclaimer. So today, I'm speaking as a cloud architect. I'm not part of the security team. SSO can be complex to implement. There are many ways to implement it. So please forgive me if from time to time I may a bit fast or take some shortcuts on some very technical details. You can implement single sign-on with many identity providers. So the identity provider will be responsible or the source of truth containing all your users' identity. On the slides, I can name a few like Okta, Entra ID, which is a new name for Azure ID, Centrify, and so on and so on. The implementation of the SSO will be a bit different depending on your identity provider. So the concept would be the same, but of course, the menus and all the remaining stuff would be a bit different. SAML, which we will use today, can be a bit complex. Work with your security team if you want to speak about SSO. You will find some people helping you to set it up properly. So today, my focus would be on implementing SSO to access AWS console. So I have two examples. We will federate with a single account, and then we will federate for a more useful use case when you have multiple accounts using Identity Center, which was named AWS SSO. And my focus would be human users, like your users in the companies, accessing the AWS console, so accessing the cloud interactively. My identity provider in the demos will be Microsoft Entra ID, so the new name of Azure ID, because it's quite, you can find it in many companies. So what is single sign-on? So SSO single sign-on. Usually, when you want to access an application, you would have two pillars. You would have the first one, you want to know who is accessing the application. So that's what we name the authentication. You want to know who is coming. And then you have the second step, which is authorization. You want to know what the users can do on that application. So the authorization or authentication, sorry, usually the most common one, username and password. So we all have username and passwords. So you go to the application, you type your username, your password. You can add some additional security measures like a second factor, a security token, physical, facial recognition, and so on. And when you speak about SSO, the idea is to have one source of truth that will be responsible for the authentication. So you will have an application that we name the identity provider that will maintain all the identities across the organization. So in the identity provider, you will have all your users. And when someone accesses an application, then the application will transfer the authentication request to the IDP, and the IDP will be responsible to say if the user is really who is claiming to be. So the IDP has to be trusted by all the other applications. So if we look a little bit at the architecture and how it works for the AWS use case. So first, the user is going to the IDP or to the application page in the IDP for that application. So we'll see at the bottom on the left, it goes to the identity provider. The identity provider will authenticate the user. It could be against an LDAP database, could use second factor. All that security part would remain in that area. Then there will be a SAML assertion coming back to the client saying the user is authenticated. Now you can go to the application. So this SAML assertion goes to the sign-in of the application on the AWS part. Then it will go to a secure token service and then goes back to say, we validated the access. So the user is who is claimed to be and has access to the application. We can finally redirect it to the console. That's the flow of users login using SSO. So in the architecture we are discussing today, we will manage the users in Entra. And technically, we will have to create what we call an enterprise application. So we'll create, within Microsoft Entra ID, we will create an enterprise application which will represent the application we want to give access to. We will assign users and groups to that application to grant them access. And we can even use a protocol named Scheme to automatically provision the users to the application. So all the users remain in Entra, and then the permissions and this authorization part will be in AWS. So after authentication, users will get an IAM role, which is defined in AWS. And then on that role, we attach policies, and the policies finally contain what the user is able to do. So it's in AWS that we will say that particular role is able to start EC2 instances, create S3 buckets, and so on. So all the authorization parts remain in AWS. Within DPI, we will recommend, because you will have many enterprise applications, please use a naming convention for your group names. Because it would make your life easier for maintaining all the accesses to the application, to just not say cloud users. Let's say you want to have a group named AWS_test_lab, where you will put all the lab users. And if you have Azure_prod_something. There is an interesting feature you can use as well when you use Entra. You can delegate those groups, manage those groups to owners. So you can easily say, we have a cloud team, which is different from the team managing the identities. We create the groups, and then we assign the groups to the cloud teams, and the cloud teams can then access users into those groups. So what are the advantages of using SSO? The biggest one, which by itself for me worth the effort, the user experience. When you use single sign-on as a user, you don't have then to remember or store another set of credentials, which is making your life easier and also more secure. Because if you don't have to store another password, it's another password that can't be stolen. It's also quite easy to manage your users. So when you onboard new users, or sadly people have to move to another team or to another company, it's easier with SSO to just manage their identities in a single place and then remove users to the groups or disable them instead of chasing them in all your applications. Of course, all of this comes with a kind of a drawback. The identity provider may be a single point of failure. So if your identity provider becomes unavailable, you can't log to the application. And any vulnerability on your IDP may have a much more broader impact because the IDP is trusted by the other applications. So if your IDP gets compromised, then the attackers can access many applications. Let's move on with the implementation of SSO. So first, we'll discuss about a single account, and then with an architecture where you have multiple AWS accounts. So even with a single account, you may think why we would need SSO for a single account, just for the benefits we discussed just before. So not having to duplicate your users into AWS is already a great advantage. So with a single account, the architecture is a bit special in a sense where you'll create the application on the left side, an enterprise application in Entra, but you'll need a user in the AWS account. You can see on the diagram that the scheme provisioning goes from AWS to Entra, which will be a bit different later, you'll see. So we don't create any users or application users in AWS accounts, but we have that user which is used to know the different roles we have in AWS. So in AWS, we create the IDP. So we have this trust relationship between the enterprise application and the IDP using SAML. We create IAM roles on the right, and those roles then are provisioned using Scheme. And then we can assign users or groups to the application to grant access. So this is how we would do the setup. So we need to create an application, enable SAML sign-on, but instead of staying on that slide, let's move to a more dynamic and look in a demo. This is the Azure portal where you want to create your application. So you'll need to check. So here I've went to it, so Microsoft Entra. If you don't have it, you can just enter it in the search bar and enter the Entra application. In the Entra application, you are interested in the Enterprise Application tab. So here, for the purpose of the demo, I've already created some integrations that we will work with. But Before, I just want to show briefly how it would work. So if you want to implement a new SSO, you would create a new application. And within Entra, you have a broad gallery of pre-configured services you can use. And you can just search for AWS, for instance. If you search for AWS, you see many different providers. And what we want to do, we want to enable single sign-on with SAML. So you can just select SAML. And now only 3 remaining. So the AWS VPN, AWS client VPN is a specific use case that we won't discuss today. So it leaves us with 2 options. So the single accounts and using AWS SSO. So for this first example, we just want to create a new single sign-on access. Let's call it with demo. And we create a new enterprise application. That should be quite fast, but depends on my internet access. Once the application is created, we don't have any SSO yet. To enable SSO, you need to go to this single sign-on menu on the left, and then you can enable SAML. So here you have, to enable SAML, you have some setups to do. So here we don't want to save it now. And now you have to go through all the steps to configure the SSO. That could be a bit long, so I won't do everything in here. What we have to remember is in this basic part, you have to configure the URL. If you have many AWS accounts which are single units and not part as an organization, and you want to have multiple, I would say multiple single SSO, you can add the dash sign and having some numbers. So you have a unique URL each time. Then you can save. You need to be very careful on the attributes and claims, but here the gallery in Azure already made most of the work for us. The specific attributes for AWS are already present, so we can see them on the top here. So the role session name, and the session duration. Those are attributes that AWS Console is awaiting when the users are connecting. So we need to pass them from the IDP to the application. If I go back to the SAML, then there is a certificate to sign the exchange between the IDP and the application. So it's mostly done in here. So I'll just go to the one which was already configured. So I have this one in here. For the single accounts, I mentioned that you need also to have a roles and so on in AWS. We will see this a little bit later. This information is used in this provisioning tab. So this provisioning part is where the scheme provisioning happens. So for that specific use case, the schemes goes from AWS to Azure because it needs to get some roles. So in that part, you can see to whom I've granted access to the application. So I granted it to 2 groups. So for the group synchronization, you need to have a certain level of license on Entra, which is, I think, P2. So you can still do it with a lower level or even the free Entra ID, but then you won't be able to synchronize groups, but only users. So that's something you need just to remember, that if you want to synchronize groups, you need a subscription a bit more expensive. And in my case here, I said that the first admins will get a role named SSO Azure AWS admin, the users would get a dev roles, and for my own accounts, a dev role. So how does it work then in from a user perspective? So from a user perspective, in that way, the users can see the application in his myapps.microsoft.com. So there are many more applications, but just here for the single account, and the user just has to click on it. If it clicks on it, then you see I've been assigned, because here I'm logged with my own accounts, and I'm part of both the admin groups and the users being Nicolas Jardot. So here I had two different privileges. So the dev one from this line and the admin ones from being part of the admin group. So I have to choose which group I want to log in with. Then let's say now I want to be admin, sign in. And that's it. I'm in the AWS console. You can see the role used in there. So from a user perspective, I don't have to enter a new password. I don't have to manage another set of credentials. When you log to the AWS console, the credentials used are temporary. So on a security point of view, that's way better. Let's go back to the presentation. So the second demo I want to show you is implementing the SSO using IAM Identity Center. So that's the new name for AWS SSO. So when you work with AWS, at DBI, we would recommend you to have multiple different AWS accounts, because you want to split the responsibilities. In AWS, the accounts contain the users, and it's kind of a security frame, if I would say that way. So we would recommend you to explore the landing zone concept and potentially have different accounts, one for security, one for networking, but you can also split from type of workload. You can say I have an account for dev, an account for prod, and so on. That's totally up to you, but you probably end with 3, 4, 5, or even more for larger organization AWS accounts that you would group in organization. Instead of creating then 5 different SSOs in Azure, you can have an organization and using AWS IAM Identity Center, which is integrated with organization, and you can manage from a single account the access to all the other accounts. So in that way of working, the user identity is still in Azure ID, but it's synchronized in IAM Identity. And then you grant permission sets. So a permission set looks like this. So the permission set is attached to an account. That's what we see on the bottom. So this permission set is attached to the account name DBI NIJ tests. It contains a policy. So for that specific use case, the policy is EC2 full access. And automatically for us, IAM Identity Center will provision IAM roles in the target accounts. So on the right of the screen, you see the roles named AWS reserved SSO underscore administrator access or underscore EC2 full admin. So the permission set we see on the left, granting EC2 full access, is this EC2 full admin. So it makes our lives a lot easier, because in the first use case, I had to create IAM roles in the AWS accounts. So if you have multiple accounts, then you need to find a way to synchronize all your IAM roles across the accounts. IAM Identity Center is doing it for you. So if you update a permission set to say one permission was lacking, I want now my developers to have access to RDS database, you update the permission set, and then AWS SSO will just update the IAM roles in your accounts for you. So that would look a little bit like, that would look like this. So in Entra, you have an enterprise application. You assign users and groups. And then you have what I name an AWS management account. So here it could be the root account of your organization, but SSO can be delegated to another account. So AWS would recommend you to not use your root account as a management account from a security point of view, because if the access to the root accounts gets compromised, then the access to all the accounts may be compromised. In that management account, you create a configuration for AIM Identity Center. And as I said, you create permission sets to which you attach policies and groups or users. And then in the many different AWS accounts you have on the right, so on the first account on the top, here I decide to provision only the EC2 role. In the accounts in the middle, only the database role. And on the last account, the two roles are mentioned. So you have the freedom to say which permission set is attached to which account in a quite granular way. The setup is not very much different from what we saw earlier. So we'll go again into a demo. So we saw that we go to the enterprise applications. And in the same way, I was able to create an application for single account access. In the gallery, you have an application for AWS SSO. The configuration goes to the same step. So you go to single sign-on, you want to enable SAML. You just need to be careful in that way of working. You can trigger the connections from the service provider. The service provider being the AWS SSO application. So when you do the setup, this SSO, you will need to exchange information in both directions. When you do the setup we did before, you just need to have the metadata information from the IDP, enter it into AWS, and it works. When you work with AWS SSO, you need some metadata information from the service provider itself and enter them in Azure. So there is a bit of configuration in AWS before. You grab then some metadata that you'll enter in there. We upload the metadata file. And in return, you get another set of metadata that you'll enter back to AWS SSO. Once all that is done, your application is ready. And you can assign users and groups. So here you see that we don't have anymore the roles, the AWS roles assigned to the users. So now I've assigned just two groups, the admin and the users, to the application. And on the scheme part, the provisioning. So if I go to the provisioning, this time it works a bit differently because we don't grab the roles from AWS to Azure. Now it goes to the other direction. So we push the users and the groups from Azure to AWS IAM Identity Center. So if we have a look on how it looks like in AWS, that would look like exactly like this. So you go to a portal, you see all the accounts. So here I'm logged with the admin accounts. So I see many accounts with the administrator access. And then I just click on an account and I'm logged with the administrator privileges. So if we have a look on how it looks like on the identity center part. So once SSO is enabled, you have that kind of screen. The first part is confirming the identity source. So here we clearly see that I'm using an external identity provider. I use a scheme provisioning method. And when you configure an external identity provider, AWS SSO then disable the user and the group management and all that part from its own internal database to say the source of truth is your Azure part. So it means I don't have any more create button for the users in there or for the groups. So the idea is not to mix kind of local users with the federated users that comes from Azure. In the user part, you can see that Adrien, for instance, is disabled. This user is not part anymore of my group in Azure. So if I look at the members here, I have myself and the dummy account for the AWS users, and for the AWS admins, I have only one or two users, both being myself in the groups. So due to this automatic provisioning, at some point in time, for a previous demo, I've granted Adrien access by adding him to the group and removed him. And that part is totally synchronized, so Adrien can't log anymore to AWS, but his account is still appearing here. So I can do some cleanup and do a delete. What I want to show you now is how it works when you want to grant access to someone. So this famous permission sets. So in the accounts part, you can see all your organization. So the AWS organization looks like a little bit of an Active Directory organization where you have organization units. So you can decide how you want to present your own accounts. So in my case, I decided to have a networking account, which will have my VPC resources that are shared to the other accounts, to have a sandbox account where the developers and the users can work. So I'll just grant the users access to these sandbox accounts. So I can just assign users groups. So boom. So here I select the groups. I can select either users or groups. And then you select a permission set. So for that case, it's developers. I don't want to grant them any administrator access. So I've prepared this EC2 full admin that we saw in the slides, granting them full EC2 to create virtual machines and so on. You have this review screen. You can submit. And here, that's where all the magic happens. So at that stage, AWS SSO created in the target account the permission set for me. So if I look to the permission set itself, EC2 full admin, Here I can have a summary of the permissions that we saw in the slides, and you can see on which accounts it exists. It exists now on 2 accounts, including the sandbox one. So if I want to simulate the connections from a user, so let's go to a browser where I'm not logged. I go to the URL of AWS SSO, and then it prompts me for username and passwords, but from Microsoft. So AWS SSO redirected me to Azure. So let's enter the credentials of my test accounts. Get the passwords from the password manager, which I recommend. We can even see that the IDP is handling the 2-factor authentication. This is also something I recommend for the access to cloud applications to enforce and increase the security by enforcing the 2-factor authentication. So now I'm finalizing the login with my dummy account. Let's skip that part because I already have 2FA. So here that's Azure that wants me to have an additional even factor for that account. And now I'm in AWS SSO, and you can see that I have the sandbox account with this EC2 full admin. And then if you click on it, then you access to the AWS console. Brand new with this federation, and you see the EC2 full admin role being used. You can clearly see that I'm not admin anymore because I have some denied access on the first page. But then if I go to the EC2 service, so I don't have anything running in there, but then I can launch instances and so on. So let's go back to the presentation again. So if we want to go further, so I've just showed like 2 examples to grant access to users to the AWS console. But we were speaking then for human users accessing interactively the console. But that's not the only use case you'd have. Let's say you need to have access to the API. So the AWS API, you need to have access key ID and secret access key. But then if you use those, you create permanent accesses toward AWS. And AWS would recommend to avoid whenever possible, you should never use permanent access keys. Because if the access key gets stolen, then the permissions attached to that particular IAM user would be used. So instead, you would like to have temporary credentials. The good point is when you use AWS SSO or IAM Identity Center, you can get temporary credentials. That's even part of the console. If we can quickly, because we have still some time, if we quickly go back as Thomas Weber user, the test user, you can see when you are on the AWS SSO web page, alongside to the role name, you have this access key button. And here it can generate access keys for macOS, Linux, Windows, PowerShell, even to help you copy them faster. Those access keys are then temporary. It depends on the session duration you specify in AWS SSO, making it perfect. So if those keys are lost or go to the nature, the maximum duration you can set for those credentials is 12 hours. So it means after 12 hours, those keys does not work. If those credentials are used to generate other credentials, let's say you create a pre-signed URL for an S3 object in AWS S3, the maximum duration for that particular URL is limited by the time of your temporary credentials. So if someone steals the access keys when there is only 2 hours left before the expiration, and they start to create other permissions out of it, it will work only for 2 hours. So it reduces a lot the exposition on and the security breach of losing the keys. But that's still a bit for this API access. It's still a little bit for humans. If you want to grant access to the applications, SAML is not restricted to be used for human users. You can have application and you can use on the AWS part, there is this STS assume role with SAML command that can be used to get credentials and interact with the API without having to log to the console. So you can have service accounts that assume IAM roles in AWS through your IDP and having only temporary credentials. But it's not only about SAML. AWS also supports OpenID. So you can configure an identity provider using OpenID, and then you would use assume role with web identity instead of assume role with SAML. That would be the same way. We have a great use case, and we are using it internally within DBI for GitLab. So in GitLab, for the pipelines and our CI/CD, we did not want to have permanent credentials. So instead, we added GitLab as an identity provider to the accounts where we have the pipeline deploying resources. And then we use GWT tokens to get temporary AWS credentials. And then we can use Terraform to deploy resources. And we don't have to worry about the lifetime of those credentials because after 2 hours, the keys are not valid anymore. We don't have to rotate anything. We can now speak a little bit about other cloud providers. Azure is a bit of a specific use case because most of time, Entra ID or Azure ID will be the company's identity source. So you don't really want to have another external IDP for Entra. And that's something I would need to do more research. But Azure by itself supports some social identity providers. So you can easily invite people having Google or Facebook accounts. It works by default for anyone having a Microsoft account. And you can create some options to work with other Entra IDs, tenants, with cross tenants to have automatically users invited and stuff like this. There is also an option that I have not really explored yet, where Azure supports SAML identity providers. From what I currently saw, it's more to grant access to applications rather than Azure to Azure itself. So that would need a bit more research, but there is an option for it. If we speak about Oracle Cloud Infrastructure, so OCI, we have 2 different use cases because OCI is still in the middle of migrating their identity and management service. So you have the option to be using identity domains. And then in that case, you can create the federation and using SAML and Scheme or just-in-time provisioning at a domain level. So you have the default domain and you can create, let's say, an Azure domain that you would federate with Azure. There is a small drawback in OCI. When you do the federation, at least in all the tests I've did before this presentation, Federation does not disable the users and the group creations within the domain. So you should be careful to not mix the local users in the OCI AAM and the users federated that comes from Azure. So I would recommend to have a dedicated domain and not use the default domain just because of this. The second option with OCI is if you have a tenancy without identity domains, so not migrated yet. Here, it still works. You can do the federation, and you can do the federation directly into the IAM service of OCI. The small difference is when you work without identity domains, then the users are not provisioned within OCI. Instead, you would have to create groups locally in IAM OCI and then mapped those local groups to some groups that would be part of the SAML claim. It means that within the Azure configuration, you configure SAML to send the group membership of the users to OCI, and then this mapping can happen. And in both cases, as I said in the very beginning of the presentation, this the management of the permissions is within the application. So in OCI, it's the same as AWS. The policies are then managing the OCI AAM. So either you have local groups or you have federated groups. You just need to be careful that if you follow my recommendation and have a dedicated domain, you need to prefix before the name of a group, having the domain name as a prefix in your IAM policies. And I think that was already a lot of information. So I'll stop in there. And if there are any questions, feel free to ask.